Boo! Hello everybody, we're going to do a Halloween CAD stream today. So Halloween is next week, and I have some funny Halloween masks that are actually left over from last year. A shop nearby me had a couple of these things floating around. If I got these in camera, there they are. Yeah, so these things are just like nice squishy foam masks, and I thought that these would make a really cool kind of will it bot type thing. So today we're going to go ahead and CAD all of this stuff up, and we're going to do what I normally do when I CAD, which is not start from scratch. So you'll see in front of me here I have a bunch of parts, and this is an untitled sketch, essentially like an untitled CAD thing. This is how I start 90% of my ant weights these days. I don't ever start from nothing. I start from bits that I've created before. So those of you who've been around for a little while might know what both of these things are that are on the screen right now. One of them is quite easy. This is Vogon Poetry, my saw bot that I upgraded last week. This is the underlying CAD for that. And then this guy over here is actually the result of last year's Halloween Will It Bot, if I remember correctly. We pulled apart a kind of devil's trident thing and turned it into a Will It Bot, which I think I still have that chassis around somewhere. So I really should dig that out and make it back into a combat robot, because I don't think it is right now. But yeah, this here is a an old Will It Bot chassis. So I'll talk about the differences between these in a second. And no, this is not a Donkey Kong mask. This one is actually it's supposed to be a vampire mask. You can see we've got little fangs. And I'm trying to do this like in the camera. I should just be looking at it. But yeah, so that's a vampire mask. Oh, and 2 years ago for the old Will It Bot. Okay. Yeah, no, that makes sense. It's been a while since I've done any kind of Will It Bot stuff, or certainly Halloween-y type Will It Bot stuff. So the difference between these two is mostly in the motor mounting. You'll see that if I kind of hide away some of these bits, hang on, actually we'll just hide away. That's probably going to be the only thing I really need to do. And we'll grab the motors and move those. Come here, move. Boop. Go back somewhere 80-ish, that'll do. So you can probably just see by looking at these that one of these is wider and the other one is narrower. This is so these guys here are actually designed, there we go, that makes it a little bit easier to see. So these ones here are designed to have the N20 stand on the side. These are for the DF robot style ones, which allow the kind of circuit board to stick out forwards where it's got space to stick out, whereas these ones are designed to have the N20s lay on their back. Now, can I do this? Yeah. So I've got, this is an old chassis out of a drum spinner, and this has got the DF robot style ones in it. So if I can do this on camera, there we go. Yeah, this is what I'm talking about. It allows this circuit board to stick out the back, whereas when I don't need to do that, I prefer the motors to sit flat, but doing that with DF robot motors means you have a circuit board sitting at the top, which is not great, realistically. So this guy, though, isn't going to be running on DF robot motors. I only really use those for spinners because they're a nice weight and space savings thing. And yes, that is Don't Need Roads. Don't Need Roads is in a bit of an interesting state right now. It should be totally fine, but every time I try and put it back together and get it working, it just falls over. So I've kind of stopped dealing with that at the moment. I really do need to just rejig the entire gearing system that I have in there and try again. We'll go back into the CAD now, though. So we have the choice of these two. Now, the other thing is what I want to do with these masks. I have done a Will It Bot before where I had the mask clamp this way to allow things to go in. And hang on, we have a question from chat. How much weight is saved with the DF robot motors over the separate ESC motor combo? A decent amount. I mean, the N20 motors, these guys, don't actually weigh, like with the extra board on them, they don't actually weigh that much more than an actual DF robot or just a regular N20. The big thing really about them for me is being able to use them with RC gear. The combination of an RC receiver and 2 DF robot motors with an N20 was like 5 to 6 grams lighter than my Arduino stack up with 2 N20 motors. So that was like so much worth it for me in terms of building spinners and that type of thing out of them. With my control bots, I would just throw the Arduino system on them, and it's totally fine for that. Yeah. Any tips for building undercutters? Yes. Don't let the bolt touch the floor. Like, don't let whatever you're running the undercutter on touch the floor, because that's not ever a good idea. Undercutters, especially undercutters with a live shaft, if you let that touch the floor, you're going to have all sorts of drive issues as the thing tries to as the spinning section touches the ground and like messes up your trajectory and all that kind of stuff. It's kind of annoying. But yeah, undercutters are good fun. Just make sure you CAD your clearances right and check everything, because the clearance matters and what touches the ground matters. Undercutters are tricky because they have to be very, very precise in how they touch the ground, because otherwise everything messes up. Okay, so I'm going to go back to the desk because, as I mentioned before, with Disguise, one of my old Will It Bot videos, we kind of did this, right? We clamped this way. So we had a chassis in underneath the mask, and we clamped down like this, which was okay. That was all right. That worked most of the time. What I kind of want to do with this is dustpan style. So we've got this guy as like a dustpan. I really don't have enough desk space to be kind of doing little demonstration pieces, but we're going to try anyway. So we've got dustpan, mask, and rather than grabbing this way, what I want to do is have the mask sit quite high and then come forwards and kind of like hold the front of the dustpan in. So kind of block escape out of the dustpan with the mask like this. Which, I don't know, I think that's going to be quite cool. It's going to be an interesting mechanism, and the arm for this is going to be insanely long to try and get this to work. But I think it's going to be really cool to have this like up, and it will hover like about here somewhere above the robot and then drop down. And what is chat saying? Let's take a look. When are you going to invite Ben to play No More Spinners? Oh, okay. Well, I guess I'll have to send you a message after this, Jevin, and we'll have a bit of a chat about that. And yeah, Mega Tento style, kind of, because Mega Tento was more of the clamp this way style, whereas I want the dustpan to do most of the work, and then we're just kind of like putting a dam down in front of the dustpan to try and hold everything in place, I guess. Also, this is going to be one goofy looking robot. That's going to be fun. So I think the first thing though is I need weight. So I have a little scale here. We're going to work out how heavy this guy is, because that will give us some parameters that we can use. Because like Disguise was a tiny little chassis inside the mask, because it had like the mask was so heavy that I just had to do whatever I could to reduce the weight of the chassis. Oh, and this thing is 10 grams. Beautiful. We have all of the weight in the world. 10 grams is nothing for a weapon. Easy. Would like a horizontal clamper dustpan work? It closes off the whole dustpan. Yeah, that could work. I mean, the problem with this is that I would kind of have to like squeeze this way with like pincers. So the mask is kind of doing nothing in that case, because you've literally just got 2 plastic arms where my fingers are right now, and that's what's doing your grabbing. So I like the over the head thing, because it's actually the mask stopping the robot from coming back out again. So I think that's what we're going to do for this one. But I have been meaning to try some kind of like horizontal grabby type thing. And also, I will say this is 10 grams with elastic in it. So there's a good possibility that we can cut some of this elastic out and it will actually get lighter. So that's nice. It will, hopefully mean that we can actually, build an interesting robot in underneath here. So the final consideration I have with this is wheels. So I have these guys, first of all. So these are my regular thick silicon wheels that I use for any robot that I kind of want to be a bit pushy and like move people around all over the place. And these are 10 grams a piece or something as well, which is not too bad. Weight is deceptive. You always look at things and go, oh, that's going to be a couple of grams, and then it ends up being like 15 grams, and you're just like, oh no. So these guys, so the thick wheels are like 9 grams, so that's not too bad, but they do need a hub in them, which is probably going to add another 2 to 3 grams to those. And then I found these in my box of parts. These are just a really old giant wheel from one of my very, very first attempts at Thwackbots, which I'm not even sure the Thwackbot made it onto this channel. Its successor did, because this was a duck-shaped Thwackbot, and then I made a hammer-shaped Thwackbot a little while after that, which did definitely make it onto this channel. Whereas, I don't think this guy ever did. But I found these wheels, and I'm very tempted. Ooh, okay, those are 20 grams for one. That's a lot. That's probably too much. Although we could maybe cut these in half. I'm thinking about this because that would be hilarious to have gigantic wheels like out here at the back of this thing. That would be amazing. Like that's an insane build right there. So I think what we're going to do is I'm going to CAD some wheels like this in, or at least mock-ups of these in, and then we're going to see if we can actually get something that will work out of this. You should try large wheels on your dual spinner Melty someday. It already has large wheels. It has massive, chunky wheels on it. Much bigger than these anyway. Alright, let's go back into here. So, actually, we're going to go back to there. Because I need to know how big these are first, before we try and put them in. 78 mil. Okay. What's my radius on that? 78 divided 2, 39. Okay. Now we'll go back into CAD. So now we need 39 radius, and what were my width on these? That was 17. Cool. Okay, so that's our wheel. Oh wow. Okay, that's massive. That is just a giant ones. Okay, so what I'm gonna do though is just work out how these look. If I go like this, turn them on this side. Yeah, so this guy is just gigantic. That is a very, very massive wheel. But I mean, I knew that going into this. This is part of the reason for even trying this, was working out if this was a good idea or not. I don't think it is. It's just going to be an interesting experiment. So first thing I do is always set the height properly. So I just measure, and then this has the ability to copy a distance, so I can do that, and now those two things are touching, which means that this guy is sitting directly on the 0 plane, which now allows me to, let's grab a second copy of this, then we're going to just snap some stuff around. So we're going to grab a motor, snap it into there, and then we're going to snap our motor mount up to the bottom of our motor, and that gives us an idea of how tall this thing is, and we're making huge. That's basically what's happened here. We've now made a huge. Whoops. Yeah. Okay. So this could be interesting. Essentially, yeah, this is going to be way up off the ground. So either we need to have massive motor mounts, which means a massive chassis, and then a dustpan scoop on the front of it, which is all sounding like a lot of weight, and then have everything mounted into that. Or we drop the giant wheels, which I don't like the idea of that. But yeah, it's starting to look too big. Yeah. Although a grabber huge would be a very interesting sight to behold. Can I do something with this? Can I do a grabber huge is the question that I'm trying to ask myself right now. Would say this might be a huge mistake. Well, I mean, it will be a huge something. So the question I have at the moment is, because what I'm thinking is, hang on, let me see if I can kind of pull this together by hand and just kind of like approximate what I'm looking at right now. So we have this guy, which is sitting high, like it's sitting all the way up here somewhere. There. Okay, that's actually not as high as it looks in CAD, to be honest. But it's somewhere about there. It is actually quite high, isn't it? But yeah, so it sits up there, and I'm wondering if I could pull a scoop down here, and then have the mask up here, and then come down. Like, that I think might work. The problem is going to be balance, I think, because the scoop wedge at the front, unless I get my weight balances correct, it's going to be very back heavy, and it's going to tip over this way. So yeah, I'd have to get really good at getting my balances correct to have the mask come down. Although I do like the idea of the mask covering the wheel. So like this, like kind of encapsulating the robot somehow. Like that, something like that. That'd be kind of cool. Somebody's saying, I now want to make a huge clamper in Gmod. Do it. Yes. Absolutely do that. But having said that, I think I kind of want to try and make the huge clamper here on stream. We'll see how we go, I reckon. So what I want then is I want a scoop out the front that comes from about there down to ground level. So what I'm going to do is actually I need to expand my ground level so I know how high off the ground I am. Come on, buddy. There we go. Okay, so how far off the ground are we? We are 25 mil off the ground. That's decent. So what I want to see, let's go radius of 25, and then if I snap this to there, that'll do. And go, actually, what I kind of want to do is make those two touch. So let's go measurement, measure that to there, copy that measurement, and make these guys touch like that. Come on. There we go. Cool. So that's touching now. And the next thing I want to do is center align these like so. And then we're going to cut this thing into a quarter so that it'll actually do things properly. Why not have it straight up from the bottom and let it tilt to make up the difference? That's going to be a long tilt. That's the problem. So if I... Actually, hang on. I'll do this real quick because I know right now it's going to be a massive tilt. So what's this distance here? That's 110. All right, so what we're going to do is we're going to say, let's just make this a square, 110 by 110 by 2 millimeters. If I now snap this to the bottom of here, and then move this all the way out, like about there, something like that. So that's our dustpan, right? And if I now do a smart rotate and allow this to touch, I'll show you what this looks like, and it's gonna look crazy. So we're gonna grab all of this, and we're going to grab, come on, let me grab that guy as well. Cool. So to get this edge to touch the floor, how far down do we need to go? That's 10 degrees. Yeah, about 10 degrees. There you go. So it's a monster tilt. Yeah. that's not great. And it's also huge. So the problem with this is that's a lot of plastic to put into this thing, because I've got a 110 mil ramp there. That's crazy. That's too much plastic in here. We can't realistically do that and still make weight. So yeah, no. I mean, and the problem is if we try and make this any shorter, so if I did this and like shortened it up by half, let's go 52, then the tilt is going to be even more insane. So if we grab the face and again grab these two, this tilt is going to be something like 30 degrees. Okay, not as far as I thought. 16 degrees. Still, oh, and that's actually not even, is that touching? Not quite. Okay, so it'd be about 17 probably. Is it 17? Yeah, 17 gets you there just. And technically we'd need to go further than this, although that's weird. Why is it touching on one edge and not touching on the other? That's very odd. Something's messed up in somewhere here. Yeah, but you can probably see by that the angles of tilt here go very extreme. So we're not gonna do that. What we're gonna do instead is we're gonna get rid of this guy. I'm just gonna move this out of the way because it might come in useful later on. Let's throw it somewhere decimally, and hopefully I put this somewhere. Actually, it doesn't matter. I'm just gonna square this back up again because all it needs to be is in the center, which it is. Sweet. So now we're going to even this out. About there. Ooh, not quite. Oh well. We're going to deal with that in a second. But first I want to cut this thing into pieces. So I'm going to take a box. This is my quick go-to way of cutting things into pieces. Not that anybody would ever use this software other than me, because you can't actually get a license for it anymore. But I take a box and move it. So these boxes that come in are 20 by 20. So if I move it by 10 in any direction, that puts a face in the middle of where it spawned. And when I snapped it, it was square in the middle of this tube that I've created. So now if I split this guy and split this way, that's going to knock off the top. And then if I split the other way, that's going to knock off exactly half of the front. Boom, 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 like that. Now we don't need that guy anymore. That's weird. What is going on there? Look at this. Something's not right here. That's very odd. Why is there a gap there? Hang on, give me half a second. Is there an angle between these two? Oh, there is. Okay, there's a 1 degree angle here. that's where my error measurement was coming from. Why is that on an angle? That's so odd. All right, let's just correct that real quick. I don't actually know where that 1 degree came from. Probably one of those snapping operations wasn't quite right. And that needs to go down a touch, I think. That's very odd. I've never seen it do that before. All right, now we're back in business. So we're kind of touching, kind of not. Yes. So the chassis was wonky, and I don't think you actually ever needed a license for 123D design, but you can't get it anymore, which is a bit annoying. Autodesk removed the downloads for it, so you can still use it. You just can't use any of its online stuff, which I never used anyway. And yeah, you can't actually download the file for it anymore, which is very annoying because it's useful software, and it's useful for somebody like me who I'm a very visual thinker. I like this type of CAD where I can just like throw shapes down and see how they line up with each other without having to like do loads of sketches and then extrude them all out, and then something doesn't line up, so I have to go back and change a lot of stuff. I can just like throw something down, and if it doesn't fit, I move it to where it needs to be before I cut holes or do whatever it is that I'm trying to do. Yeah. Anyway, having said all that, we've got our little scoop here, and this scoop, all we're going to do is we're going to subtract, take away the middle section, and there we go. That is one old scoop. What I might do with this scoop though is do a bit of an abstraction on it. So we're just going to like scale it in weird ways, scale it a little bit that way, and scale it a little bit this way. Now, I will say the problem with doing this is that we now don't have a flat surface that we can 3D print. So I'm either going to need to do these in 2 separate halves and glue them together, or I'm going to need to print a bunch of support material in under here, which, I mean, that's possible. That's very possible to print some support material in under there. Might be worth doing, to be honest. Also, I've just realized too that this front wall here is super thick. It's probably what, like 3 mil? 6 mil. Oh, wow. Okay, we do not need that much plastic up the front there. Let's grab hold of that and drop that down by 4 mil. Because that was taking up a lot of space inside here, and we really didn't need that to be a thing. Yeah, so this motor came in. There we go. That's the issue. This motor came in on an angle, which is making me think this wheel might be on an angle. I kind of have a feeling it is, which is very odd. Oh, maybe when I turned that 90 degrees, I didn't actually fully turn it 90 degrees. Maybe that's where all of my issues have come from here. Let's just drop that like that. There we go. Hopefully we're still making contact. We should be. We'll also get rid of this guy because that's going to be offline now. And then we'll copy that over. Just pump another one. Let's go 130. That should do it. Cool. All right, so that is our scoop. Actually, I swear I copied that. Cool, whatever. We'll just do that again. There we go. So that's our scoop idea. And then we're going to turn around and throw the mask on all of this. So the question for me here is which of the 2 servos I want to use. So I've got a high voltage servo in the back out here, and I've got a just a regular old 5-volt cheap nasty servo over here. I think I might throw the cheap nasty in this one because I think that's going to work better for me. Yeah. Look, I really respect anybody who can just like grab a design from their head straight onto paper and like bust that out. But yeah, when I do CAD, like cardboard aided design, it takes me 4 or 5 attempts at like blocking everything out on sheets and folding cardboard together to get things to work nicely. And realistically, when I design in this type of CAD, it's kind of the same. It's just that it takes me a lot less time to like dump this part up here and go, oh, no, that's not quite where I wanted it. Whereas when I do like pencil, paper, cardboard design, I like do everything out and then I fold it all together and go, oh, right, the servo is in the wrong spot. And then I have to back out and redo everything. So yeah, I like CAD to just like really quickly get things up and running and going. What's the weight difference between these two servos? Kind of crazy, actually. This desk, I need more space on this desk. And weirdly, it is the good high voltage servo that is lighter, the lighter of the two. So here we go. You guys can see that? Yeah. So the cheap and nasty servo is 11 grams, and the high voltage servo, 5 grams. So there you go, half the weight. The only thing I don't like about these is they're only 90-degree action, so they're like here to there. Whereas these guys, the cheap ones, the cheap Metal Gear ones, are full 180 degrees, which is kind of nice. But it does mean that in the model, I'll actually have to like make enough room for the arm to be in the full range of swing, or I need to set the transmitter to only do half the swing anyway. Cool. So that's where our servos are sitting at. And yeah, what I'm actually thinking is if I throw back to here, I'm actually thinking that we halve down the width of these wheels. So they're going to be 10 grams a piece. So what did I say? That was 17, which is what, 8 mil? Let's just knock 8 mil off both of them. This is going to make for one hilarious looking robot. So there we go. The other thing I am thinking is maybe I do change this scoop up so that I can print these in 2 separate pieces and bolt them together maybe. Because that's going to make for an easier print for the 3D printer and without having to print a whole bunch of support material in there. I do like the nice big scoop, but if I do something geometric, it will help out quite a lot in terms of being able to print that nicely. Alright, well let's just quickly throw a different scoop on here. I know I just sat down and built this scoop, but we might be able to do something a little bit different. So, what do I want? I want 6-sided shape, I think. 25. I'll do 6 sides. No, I want 8 sides. That was what I was thinking. That'll give us an interesting looking scoop. So we're going to stand this up here, and we're going to do what we did before, where I measure from here to there, copy that, move this in. There we go. No, come on, negative. Done. Cool. So those should be technically touching now. And we're going to use this as our scoop this time. So I'm actually not going to cut this in half. I think I kind of want to cut across this corner here. So let's snap this guy in here. Oh, actually that's not what I wanted to do. I wanted to snap this guy to there. And then work out what's my difference between this corner and that corner. 0.433. Gross. Weird number, that one. Minus 0.433. Done. Cool. So now we're going to cut this again. Body, split, bam, bam, bam. Do that. And I'm going to do the same for this other face over here. So I'm actually going to pull all of this out so that I can get to the back. Again, go boop, boop. And I bet you anything it's going to be the same value. Between there and all the way in. Yeah, 0.433. Of course it is. Cool. Minus 0.433. Bam. So this is going to give us an interesting shaped wedge. Not particularly spooky in this, but we'll see how we go. So we'll delete that, and now we've got our kind of weird cut shape. And again, I'm just going to make a 2mm thick slice out of this. And the way to do that, actually, we're going to go all the way off canvas. Over here. 95. Cool. So now all of these faces go -2. Like that. And jam this back in here. Boom, and subtract. Hopefully that's everything. 1, 2, bam. Okay, cool. So that's our scoop. And this scoop, we can then put these holes in and we can secure it. 45, like that. Awesome. So that is now a scoop that we can use and actually print as a separate piece and yeah, either glue together. Actually, I might acetone weld this together because I like acetone welding at the moment. It's been quite useful. So there you go. That makes up some form of scoop, and then all I need to do is work out how far that is. 44.98. That's also, that should have been a nice flat number, but apparently not. 44.98, like so. Bam. Okay, so there we go. That is one scoop. Actually, we might do the same trick we did last time and just scale. Oh, actually, we don't need to scale this time. We can just push pull, and it should do what we want it to do. Like that. That'll do. And we'll push pull this way a little bit as well. 16. Perfect. So that's a very, very, very scoopy robots. But 2 or 3 of those scoops would work well with the design. Well, maybe. I mean, this is a very weird design all round, so who knows what's going to work with this. How about making teeth along the edge of the scoop to make it look a little bit more like a lowered... ooh, that's an interesting idea. I'm not sure how well my CAD skills are going to do that, but that is interesting. I like that idea. Oops, spilled a bit of water. That's unfortunate. Oh well. It should be okay. Yeah, how do I do teeth here and make it make sense and also not impede the ability of the scoop? Because that's the other thing. The scoop needs to be able to pick up an opponent. So actually, first of all, obviously, we need to put a chamfer on this so that it's clear this is the hit point. There we go. Nice little chamfer. In actual fact, we can do a double chamfer just to kind of lower that a little bit further. 2.5, 6, 7. There we go. That'll do. 2.7. So that's given us some form of slope like this. There we go. The Gmod 1 is coming along nicely. Cool. That's good to hear. I wonder if I carve teeth points into this, like make a, rather than have it as a scoop, make it more, what do I want to, like more fingers, like more a dustpan, more like this guy out the back here. That might be the way to do that, actually, in terms of like making teeth out of it. So let's see if we can do that real quick. No, not smart scale. That was the wrong button. This one, align. There we go. Okay. So what I want to do is, Let's make, yeah, we're going to make rows of sharp, pointy teeth. You could have the very front of the scoop raised like a speed bump. Yeah, maybe. The problem with like speed bumps and stuff like that is this type of scoop, you want your opponent like all the way up in there. Like you want the scoop to get as much grab as you possibly can. So a speed bump kind of like they hit and then have to go over a bump, and yeah, it gets a little bit weird. So here, let me just try something. Let me see what I've got, and we'll see what happens. Oh, hi Mark. So we've got 4 mil right now. That's what this guy is. He's 4 mil thick, like so. Cool. And what I'm gonna try and do is, what's gonna be the easiest way to do this? I think we're literally just gonna have to like, yeah, split this. So split, bam. Yeah, okay, I'm gonna do it this way because it's gonna be easier than like continuously splitting, I think. If we do, move this guy, I'm just gonna get it out of the way somewhere actually. Let's put it at 150. I like to put everything at decimal numbers or at least sets of 5 so that I can like move things back and forth really quickly. Because if something's at like 147, then it's hard to remember 147, where if it's something's at 145 or 150 or 155, then you can stop at the 5 or the 10 and you'll know things line up where you want them to be. The same thing that makes the scoop difficult to get onto. Right, the same thing that makes it difficult to get on the scoop will be the same things that makes it difficult to get off the scoop. That is a good point. My counter argument to that is you need to release. You need to be able to, at some given point, release your opponent and have them move again. So I don't like passive forms of grappling people because they're not something you can actively release, which, yeah, at the bare minimum means that if you use them properly, you're going to need to have the arena open multiple times in a match to have somebody manually separate robots, which is just putting people at risk. Like that's the ultimate end of the story there. If you're going to have something that grabs hold of your opponent and doesn't let them go, have that remote controlled so you can actually let them go when it's the 10 seconds or the 20 seconds or whatever your competition allows you to grapple for. I really am not a fan of passive grappling. It's not, yeah, it's not something that I condone in any way. So the idea I had here is we're going to try something a little bit interesting. I'm going to get rid of, actually, I don't need this guy now. He can just disappear for the moment. I'm going to push this back out. Hopefully get back to there. And I'm going to push this back out. I don't know if I need to, actually. I'm going to do that again. If I do a fillet, am I going to get a tooth looking shape? Oh, that's a canine looking shape. And yes, Mark, I agree. You can, if you have something in a scoop that's stopping somebody from getting back out, then you are definitely going to stop fights, which, yeah, no, thank you. But yeah, so there we go. We've got a little like canine looking tooth here. So if I now copy this and move it over by 4, look at this, we're going to get a set of teeth here. So if we copy this again and go further over, 8 mil. Oh man, this is going to be kind of gross, and I really kind of like it actually. So whoever suggested teeth, thank you. Because this is a madhouse. Copy all of those. Paste all of those. So that's 30. That's a lot of teeth right there. And now I'm going to do that again because I don't think we need a full set like that. Oh, okay. Now, to make this more teeth-like, what I'm thinking is that we separate these and widen some of them out. Because I think that if we like change the width of some of these, we'll get more of an actual like mouth look by having different width teeth in there. This is going to be disgusting, but hilarious. So let's do it. And this is also definitely not where I saw this robot going when I turned the stream on a little while ago. This was the furthest thing from my mind. Sure, okay. What I want to do actually, maybe I'll make my life a little bit easier and make the teeth semi-symmetrical. So what I'm going to do is I'm going to do this and move this back 10. So this is our midpoint marker. And I kind of want, so we're going to start just like deleting kind of at random, like this, and we're going to fill these gaps. So I'm going to shuffle and then shuffle. I want you to go half of that distance. Nope, 0.5 like that. Oh man, this is going to be gross. It's going to be awesome. You think I misunderstood what you meant. The speed bump will be able to be driven over in both directions like a speed bump. But that and help with the combination of the top jaw will help hold an opponent. Sure, the speed bump can be driven over in both directions as long as your opponent still has grip on the ground. The problem with the speed bump is if you have a bump sitting like this and somebody drives over it and gets high centered on it inside your dustpan, then they don't have touch on the ground anymore, so they can't actually back off anymore because they're high centered inside your own robot, like inside your robot, and you have no active ability to kick them back out of there. Whereas if you had a front lip and you had a servo on that front lip that raised it, and so you were high centering on something that you had active servo control over, totally fine. That's great because you can drop it back down, they'll get their wheels back on the ground and they can drive off again. The problem with any kind of speed bump is there is always the possibility that somebody can drive onto it but then not get back off again without help. So if you're going to put a speed bump in, have it be actuated so that you can help somebody get back off again when it's the 10 seconds is up and it's time to let go. It's a sportsmanship thing for me. I don't like, look, I can see you wanting it as an advantage, but personally I see it not as an advantage and more of just as a nuisance to both sides of the fight. Okay, I am going to go back to teeth, which is not a sentence I was expecting to be saying. Okay. That didn't do what I expected it to do. Let's make this worse. Yay! Oh, that's a weird tooth. Oh, okay. Yep. I'm just gonna carry on with this because, yep. Let's do 1.5 on this and see what this does. Okay, these teeth are looking mighty weird, lads. Let's round this off. No, oh, we can't. Okay. How do I make these teeth again then? Or do I not? Maybe I yeah, I could also change some length up. That's an interesting point. Let's see if I grab one of these and go push pull and like throw. Oh yeah, there you go. That's kind of gross. Okay. All right, realistically, I should probably have left the original tooth without the rounding on the teeth to make this easier to do. How? Okay, I've got an idea. So what we're gonna do is we're going to undo some of this work. We're going to take big old chisel tooth here, which is like there, and we're going to get rid of basically no, not that. Stay here. Get rid of basically everything else, and we're going to leave big old chisel tooth. Actually, big old chisel tooth is now going to be small tooth. We're going to make wider tooths from here. Nope, don't do that. Here. Okay, so that's now lined up with one edge. So we're going to take this guy and we're going to copy him and we're going to move him over, and then we're going to make this tooth wider, and we're going to drop this tooth in by, let's go to mil, like that. I'm going to take this guy again, I'm going to copy him, I'm going to go all the way over to there. Actually, this is going to be our canine, I reckon. So this one's going to be just a touch smaller, like that. Then we're going to, he's going to be longer too. So that's going to go out by 2, just like that. And then this guy again, Control V, Control C, out to here. Also wide, but not as wide as the other one that we had. Just a touch. But also a little shorter, like that. And then once we've done this, we're going to round all of these up, and we're going to, mess with this a little bit. So matching the skull, not a huge deal. The skull's teeth are actually quite large. They are, where's my calipers gone? I didn't think, let's take a look. My calipers say 9 mil for the largest of the teeth. What's my plan for preventing the front raising up when I accelerate? I don't know. Maybe maybe some wheelie bars out the back, I reckon, because this thing is gonna want to wheelie quite heavily, so we'll have to deal with that. So my calipers say the teeth on the mask, this guy, the bigger teeth in the middle here are like 9 mil, so we'll just double check that we're okay within that. 14 mil. Ooh, okay. So we do actually need to shrink some teeth down. Again, weird things to be saying in stream, but that's fine. So that should be 9 mil. Sweet. What is this guy then? He's 8 mil. Okay, so that's fine. So we've got an 8 mil and a 9 mil. And then this guy, this is our canine, and he's 7 mil. That's totally fine. Like that. And what are you? You're probably too wide as well. Oh, also perfectly 9 mil. Awesome. Oops, that's not what I wanted to do. Don't do that. Grab you and do this. Do that. And probably 2 more teeth. Actually, we might do one that's thinner, but the regular size. Like that. And then we'll grab another one. All the way over like this. Okay. No, I want mini tooth. There we go. I should delete all of the rest of these because I don't actually need them anymore. That was way too much teeth in this mouth. Okay, so I'm gonna actually do, I think maybe 2 small ones at the front. Like really small ones, like half size. And a little bit longer. Cool, okay. Oh, but we're not anywhere near the middle of the mouth yet. Whoops. And we're just going to do 1 mil back on this guy, like that. And we're going to take a final big guy. That should get us to the middle. Oh, okay. I'm going to get rid of that because I want to be able to mirror all of these around the center point. So I need to be able to do this. And actually we're gonna do that and just get them to touch. Do they touch or do they go through each other? Unsure. Let's take a look. Oh, that's cool. So yeah, in chat you're saying you had a fold-out wheelie bar that worked from the grabber. Yeah, so that's a cool idea. And I mean, I've done similar things before. So while the mask is up, we could have a piece that kind of like drops down the back and stops the robot from wheeling. That would work. That would work really well, actually. So I want... Do we want to make this tooth thicker or do we want to make the tooth... Yeah, let's make this tooth thicker. Cool. Okay, so now we have a set of teeth. Weird teeth. And we are going to fillet all of these to make them weird teeth. Okay. Give me half a second while I fillet some teeth out. Just, oh man, what is this? What is this stream? I'm gonna do some, like my wider teeth aren't gonna make perfect points. They're gonna be kind of flattened like this, because I think that makes sense in a way, in a weird way. That. This guy is going to be sharp. Was that guy supposed to be sharp? I can't remember. So look at this. We're getting some weird looking wedge stuff that's happening on the front here. Random tip, if you spray WD-40 on RC car tires, it gives them more traction. Yeah, so you're breaking down the rubber and it's actually gumming up a little bit. You can, weirdly, you can buy, like RC people, like the people that race RC cars have rubber traction compound, which essentially is kind of like WD-40. It just breaks down the outer layer of the tire and gives it so much more grip, which is interesting. But yeah, like I said, I'm pretty sure the stuff that the RC car guys use is not WD-40. Like they've got some special different compound that you can buy that does that for you. Personally, I just use silicone wheels, and silicone has decent grip without having to like break down the outer surface of it. That is the other problem, of course, with doing that method, is that you're breaking down the outer surface of your rubber, so the rubber lasts less time, essentially. It'd be funny if one of the teeth had a cavity in it. You know what? Sure, let's do that. 1 mil, bam. We're gonna grab hold of this and we're just gonna put a nice big old splotch through a tooth. There we go. Subtract tooth. Cavity, bam. Okay. Cavity installed. Actually, no. So I'm going to remove the cavity just for half a second because I'm going to mirror this stuff over. So I don't want the cavity to be mirrored because I'll do more cavities once I have done the mirroring. So we're going to take all of our teeth. And we're going to mirror them, and then I'm going to move them around a little bit too, so that we don't have a nice even set of teeth. Because right now, I think that's a little bit obvious that it's all just mirrored. So what we're going to do is we're going to start like, oh, don't do that. Come back here. So I'm going to move this tooth out of the way entirely. Out to 50, that would do. And then we'll move this tooth, and we'll just kind of play tooth shuffle, I guess, for lack of better words, because why would there be better words in this stream? There and there, like these things, these teeth have to match back up again, like because they all have to fit in at some point. They should. Let's make sure I'm not lining these up by height order here. Do that and that. You guys can move across here. This guy can move back over here. Oh, this mouth is weird now. I say that like this mouth wasn't weird before. There we go. One tooth shuffle. And now we're going to make some more cavities. So we're going to copy this guy and move him over here somewhere. Copy again. I'm going to make some bigger and smaller cavities. How many cavities should we do? Let's do a double cavity there. Again, not things I was expecting to be saying today. Whoa, that's a massive cavity. No, stick with me. There we go. You know what? That I think will do. Just like that. Okay, now the other thing I want to do is I want to get in real close, and I want to grab this and move it over by, that's probably 0.1, I'd say. 2? Yeah, that'll do you. I just wanted to make sure those overlap so that when I go to merge this body back together in a second to make this front wedge, it will actually merge and be a proper thing. So now we're going to do a whole bunch of subtractions to get our cavities in place. So one cavity there. Oh, that's a big one. Somebody's eaten way too much candy. This guy. Where's our next? Nope, not that one. Want to subtract again, this guy and that guy, and bam! Some of these are interesting looking cavities. And this is a monster cavity here. Bam! Oh no, that's rough. That's half your tooth gone right there. What? Just... Okay. So what I'm going to quickly do is going to remove the ground, and I'm going to select all of these and make a copy of them. Because if I want to come back and make changes to this, it's so much easier to make a copy and have a copy just kind of floating off in the ether over here than it is to try and unmake the thing that I'm about to do. So we're going to merge all of these teeth all in one go. Bam, 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 bam. And we have teeth, kind of. Oh, interesting. So you can't really tell that there are teeth. Hi, Mark. So, I want to know what you guys think. Do I chamfer these a little bit so that there is some edge on them, so that there's some like concavity to them so you see the teeth? Or do I leave them alone so that you can only see the teeth kind of out the edge here? What do you guys reckon? And while you are kind of dealing with stream delay and stuff and getting comments to me, I will work on the rest of this. So what I'm actually going to do is I'm going to put the bigger, heavier version of this in because I think it's just going to be better and easier for me to do that. I just need... Don't do weird things. It's not what I want you to do. What I need is to do this. so that I can merge this stuff together. Bam, 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 and throw a merge on all of this stuff as well. Okay, chamfer them, a bit of show on the edges would be nice. Cool, all right, I agree. You could create a gum line above the teeth. I like that idea actually as well. So I am designing a Willet bot using this mask, which we're going to clamp over top, which is going to be an interesting design. I think we'll get to that in a second. And the software I'm using is Autodesk 123D Design. It's actually software you can't get anymore, but it's software that I really, really like because I'm a very visual CAD designer, and this software is just a good representation of how my mind works. So it makes my life easier in that respect. So what I'm actually going to do here is we just did this, so I don't want to undo this. I'm actually going to delete these teeth. This is why we made a backup copy of teeth over here. So this is our backup copy of teeth. We're going to copy our teeth, move them back into place. It was 190, I believe. Yep, looks that way. Okay. So now what I'm actually going to do here as well is I'm going to put a box down, and I'm going to put the box about here, I think. So this is going to be, what is the best filament for 3D printing? There isn't one. Here's the thing. It's the best filament for 3D printing, for robots is the one that you can print realistically, because PLA works and works okay for most ant weights. ABS is better for ant weights because it is lighter and tougher than PLA. Nylon is good, but is a massive, massive, massive pain in the ass, and only to print, and only gives marginal improvements over actual ABS stuff. So if you have to outsource your 3D printing to somebody else and you're trying to print 2 chassis per event or something, it gets expensive really, really quickly, and it's not as worth it in my mind. And then carbon fiber, nylon, and that type of stuff is crazy. Mark brings up a good point. TPU is really good. Flexible PLA is also really good. The problem with those is you can't print a full chassis in them. You have to have something rigid in the middle to actually hold your motors and stuff together, because otherwise the whole robot is just flexing all over the place. I do have a TPU chassis somewhere, not in this room. And yeah, it is crazy how weird things get if you just have a full TPU chassis. It's really, really great for armor panels, but you need some structure in underneath of it to actually allow the robot to move properly. Can anyone imagine putting a 21-gram metal servo in an ant weight? It would absolutely take up half the weight of the ant weight. It would be an impressive feat, I would say. But I need to get back to what I was doing, which was mutilating teeth. So we're going to start going down the line, and we're going to split all of these teeth. It's going to take me a little second here. Oh, I can Alt-B this. So that's what we're going to do from here, because... No. Bam, bam. Alt-B. Cool. This is going to take me just a second here. Oops. No. Click off that. Damn. Body to split is that one. Okay, here we go. So I'm going to create a gum line by doing this, so it will all be worth it in half a second once I'm back up and running here. Body to split, splitting entity, bam, bam, bam. It'd be nice if I could do just a massive long line of these, but I don't think I can without making it do weird stuff, which I don't want it to do. Just going to keep hotkeying everything about this. Splitting, bam, bam, bam. Almost there. Got our very damaged tooth here. Split, bam. This is also probably the most art bot I've ever done, or I've done in a while, I should say. So here we go. Okay, now, what we're gonna do with that all done and dusted, we're now gonna grab all of these edges. Oh, that's gonna chamfer. I don't like that. I kind of wanted it not to do all of that. That's all right. We'll only do a small chamfer because it's grabbed everything. Whoa, we've zoomed through the page. There we go. See, it's grabbed the top edges as well. I kind of wanted it to only do the sides, but I guess we've got what we've got. Okay, so all of those are grabbed. I'm just going to do a tiny little bit of chamfer. Yeah. Half expecting that to happen. That's annoying. How do I fix that? How do I chamfer these? Alright, well, we can do one at a time. Come on. Is this more artsy than a dinosaur bot from a few months ago? Yes. At least the design of it is. Yeah, the design of the other one, I did have to create the fangs that came round and down into the dustpan, but they were easier to do and less intensive than making a full mouth with, yeah, half-bitten teeth and all sorts of weird stuff going on. So, the question I have for myself is, how do I do this in a way that makes sense? Oh, I know what I can do. Rather than chamfer, I can reduce the teeth a little bit. So if I do this and grab hold of any exposed edges, like this, I might be able to separate these a little bit. It's going to be a weird one, I think. That's not what I wanted. Oh, that's one I want. That one. So if we do like -0.1. Ah! Okay. These teeth are tricky. See, the problem is I could go back. I could go far, far back, and I could undo these front chamfers, and then we could chamfer in the teeth. And that would work. That would work okay. Or. Oh, I know how to fix this, I think. Alright. Let me try this. I'm going to grab all of my teeth. I'm going to knock a bunch of distance off of all of them. Nope, not you. There. 5 mil? Is that going to be enough? Probably. Damn, now I have to copy all those again. This is interesting. Yes, yeah. This is a 150 gram robot. So wheels are about 10 grams, and then the mask is about 10 grams. So the chassis I'd aim for probably 35 grams, I think, to try and get this all to work. So just trying to make this work out in the nicest way possible, and it is fighting me a little bit. I think the problem is mostly how many teeth we have. We have a lot of teeth. So, how do we do this? I've also been streaming a while, haven't I? Where are we? How long does it tell me how long I've been streaming? Oh, over an hour. Okay. And I kind of want to get at least this dustpan done before we wrap up the stream here. So, I guess the other thing we could do is smart scale. Yeah. If we edit the grid, we could smart scale. That will create individual teeth, because teeth have gaps between them. Yeah, no wisdom teeth. Although I could just like CAD a weird ass tooth sitting out the back here. That could be a thing. Okay, this is what we're going to do. I'm going to undo all of that. All right. What we're going to do is we're going to turn our snap grid, linear snap grid, to 0.1. And I'm going to grab each tooth, and I'm just going to like throw a little bit. That's what we want to do. There we go. This will look okay, I think. Yeah, see, we're just going to have like slight differences between teeth, which I think could be okay. What kind of materials do you use to keep weights in this light? ABS mostly is what I use, or that's my go-to when I want to keep things as light as humanly possible, or as possible for me with my current capabilities. You can also use HDPE. I did that on my sawbot this week. I put HDPE front armor on because, yeah, HDPE is lighter than most other plastics. Oh. Okay, so just going to squeeze teeth in kind of a little bit. This should be okay. We'll have a slightly separated teeth. And it will also kind of mess up the teeth a little bit, so they're not quite as uniform looking anymore, which will be interesting. And then I can also probably buff each of these back teeth just a little bit, just like raise them up just a bit, and that will, yeah, actually no, because that would create, oh no, it won't create a speed bump because it will be just an edge. Yeah, I don't know, I might leave that. We're creating a dustpan grabber robot with a spooky skull mask to be the grabber. We're going to grab this way, so the teeth are going to touch the ground and stop the opponent from getting out of the dustpan, which could be interesting. And yes, I see a lot of people use a lot of interesting materials in ants. Personally, like I said, I use ABS mostly because it just is easier for me to work with than most other things. Okay, we're going to hide that in there. That's cool. So we've got some little gaps going. This is going to print really weird, I think. the printer might not handle these tiny little gaps between teeth, so we might lose a bit of distinction, but I can also go back in with a knife or a chisel or something and kind of give distinction back to these teeth, which... It's going to be a weird build. This whole thing, just, look, I'm enjoying this. This is great. It's just nowhere near where I was expecting to be today. Smart scale. We're also just going to do one. Let's do a bit of a gap on one of these teeth. And we're going to make this a mutant tooth too. It's going to be just slightly taller than its brethren for no apparent reason. And by taller, I mean like one layer line taller. So you'll have no idea in the final print. But, you know, we'll know. Those of us who saw the stream will know. So, finally, here we go. Last tooth. Done. Now we have some jagged teeth. Look at that. And they're going to look like actual teeth now. This is cool. It will probably be printed in white, but then I could spray paint and or actual paint a bunch of this stuff and have it sit down. So we're going to, before we merge up, we're going to copy all of this stuff again because I don't want to lose all this work. That was so much effort to get those teeth to be actual teeth. And now we just test to see if my computer likes this amount of parts and also streaming all at the same time. Come over there. Oh, and my snap grid is set to weirdness. All right. All right, snap grid, you're going back to 1 mil. I can't work in 0.1 mil. That's gonna throw me right off. Okay. Now we merge all this stuff back together and we should, fingers crossed, have a decent looking set of teeth. Merge, 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 merge. Doop, 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 doop. Bam, and then we'll merge these in as well. It's tooth time. Teeth, 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 teeth. Bam. Oh, how weird is that? Oh no. Yeah, an opponent is definitely going to chip one of these teeth, especially if we put it into a class that has vertical spinners. What are we working on? Chip teeth. I'm glad that you guys are enjoying this. Like I said, I am very, very much enjoying this as well. It's not what I expected, but I'm having so much fun with this. And I think I'm going to have to print this way, so we'll print it with these at the bottom, and then there'll be maybe support material in under here, but that'll be okay. And I might have to strengthen this part up if I'm going to bolt through into it. All right, so question now. Where do we go from here? I guess we need to get some semblance of our spooky mask guy into here to see where we're currently sitting. So we're going to go down to the desk. And yes, it is tooth time. Oh man. All right. Yes, this is psychological warfare. This is what this design is. It's going to be ineffective for everything other than just psyching my opponents out as soon as they see this thing. So I need to work out how big this mask is in some kind of general sense. So I'm just kind of going to give it a rough measure. We're looking at 138. Oh, that is wider than the design currently sits, which I guess is good. It will supply a little bit more. Oh man, I need to get my opponents to swear to the tooth, swear to tell the tooth. And we're looking at 11 mil thick on the lip down the bottom here, and it's an arc about 60. The thing with this mask though is it's so flexible. It doesn't really matter. Oh man, that's That's a bit disturbing, that sight, the eyes popping out. Actually, you know what this reminds me of? It reminds me a little bit of a gorilla face, but it also reminds me of the aliens from Indiana Jones, the bad one, the last one. Yeah, okay, so anyway, I'm going to put something into CAD here that's kind of approximating this. So what did I say? I said like about 130 wide. By clamping it a little bit. Yeah. 130 wide and like 60 deep. Okay. It does look kind of cool squished, hey? But squished like this, it is completely useless. It has no ability to grab anything. So we're not going to do that. Anyway, back to the CAD. So I said about 130 and about 66. So what we're going to do is we're going to do 130 by 66 like this. Now this is one of the rare times I will use a sketch plane. And we'll run this way. And do this because now I'm going to create an arc across here, which will be my kind of guide rail for this little thing. Is downforce going to return? I don't know, maybe. The design was interesting and it was good fun. I stopped using it a little while ago, but I guess I could go back to it at some point in the future, maybe. I don't know. We'll see how we go. I'm liking the saw blade bot at the moment. I'm kind of building or fighting less ants, I guess. Okay, so this should be the arc-ish of our mask, and then we can use that to split this solid. So that will delete those. Okay, so this is going to be the arc of our mask, and again, what I'm going to do is I'm just going to grab hold of this, make another copy of it, and move the outer edges back 2 mil. So we'll just throw that up here. Because if we throw this back 2 mil and then go down and cut, then we'll have a perfect outline of what we want. There we go, like that. Actually, I can just extrude this. That's going to be easier. Bam, done. Okay, so we now need to throw this 180-degree arc, like so. And I want to move this to over here. So this is where our mask is kind of going to line up. But as I said before, the mask is quite squishy. So I could very probably, kind of adjust this angle a little bit so that I could get maybe a little bit wider out, I think. I might do that. Because, hang on, what I'm going to do real quick is actually I am going to adjust the scale on this a little bit. Let's go 4 on each. No. It's fighting me today. Okay. Cool. So that's expanded this out just a little bit, which actually covers those wheels quite nicely. And now what I'm going to do is I'm going to make a kind of semblance of what I think the mask is going to end up looking like on this thing, which, oh wow, that's like 80? 90 to the bridge. Ooh. How expensive or complicated is it to get into fighting robots? I'm going to agree with the comments here saying it depends on the weight class you get into. If you aim for something like what I'm doing, which is an ant weight, your first one is probably going to cost you in the order of like $100, $150, but most of that is going to be your transmitter and your receiver. The rest of everything, especially if you 3D print your chassis, use N20 gear motors or DF robot ones, because they plug straight in. All the electronics and stuff are fairly fairly cheap. And like I said, the big purchase is going to be your transmitter and your receiver. But once you've got those, like me building this robot, this mask cost me a couple of bucks. The print's going to cost me a couple of bucks. And the electronics I throw into it's probably going to cost me like 30 bucks. So overall, probably a $50 robot, less than... Oh, pardon me. Yeah, so it gets cheaper as you build more of them because you're just kind of reusing parts more and more, essentially. And yeah, I'm going to say that ant weights are definitely, like 150 gram ant weights are the best place to start because you can 3D print a chassis out of ABS or PLA and have it survive fights. US 1 pound ant weights, you can't do that. You need better armor or you need to print in a higher class fancy material if it's going to survive its combat. So yeah. You go for a 150 gram ant weight. Okay, so what we're going to do is we're going to do a semblance of this mask. Now, I just measured this and it's kind of insane. So that's 20 mil tall. We need to go up a further 60 mil. This is not going to stay like this forever. But it's going to stay here for now. So that is as tall as the mask's eyebrows are. So I still have to do a bit more to this, which is kind of scary. So we need a dome on the head, and the dome on the head is... What are we looking at? A further... Oh, wow. It's a further 50 up. That's interesting. Radius of 50. Oh, actually, that's not what I wanted to do. Don't do that. Nope. Come here. Goodbye. So we want to put that right on there and do a radius of 50. Oh, boy. So split. Body to split. This guy. Splitting entity. Nope. Can I grab this surface? Yes, I can. Cool. Do that, do that, do that. Man, oh man. All right. So what I'm doing is just creating this facade so that I can work from that and I know what I'm dealing with. Bam, bam, bam. Delete all of this. And delete that. And now we're going to take this and pattern it. What do I want? Which is sweep. Oh yeah, it's going to be that. So this needs to move back by 50. Nope. Is this the right way to do this? Let's try it. I have no idea. This could fail drastically, and if it does, we'll try something else. Profile, path, that. Oh, boom! Look at that. That is beautiful. That is exactly what I wanted. Nice. Okay. Alright, let me just catch up on track because I've kind of got distracted doing that. But there you go. This is our mask substitute. In fact, I'm going to make this white glossy plastic so that we know that this is our mask substitute and this is where our mask is going to sit. So we're going to need quite a long arm to get into here to deal with this thing. More people entering and leaving. There's a plastic ant weight class as in the US. The plastic classes are good to start with. There's also a plastic class here in Adelaide where I fight in 150 gram ant weights, and those are good because they're way less destructive, which means that you can be sure that your robot's going to survive for an entire event and you're not going to have too many repairs afterward, which is always nice. Because things can get destroyed in the open classes. Yes. Heavyweights are very, very, very expensive. I've seen numbers thrown about, and I've of course budgeted for one as well. And anything shy of about $10,000, like if you're putting in less than $10,000, you basically don't have a combat ready heavyweight, which is insane. Like it's so much money to get into heavyweights, and then there's only one place in the world you can really fight them, or maybe two. There is a live scene in the UK where you can fight them, but then there's also battle bots. So it's difficult. Heavyweights are very, very, very difficult. Yeah, so 3D printing like anything else. It's a machine and a technology, right? So it depends on how you 3D print the thing that actually determines whether or not it's going to be smashed to pieces. It's a tool. So once you gain tool proficiency with a 3D printer, you can do better things with a 3D printer. So yeah, I'm not surprised that some 3D printed bots get smashed to absolute smithereens, but at the same time, I print most of my bots, especially in the 150 gram class, and they survive okay because, yeah, I have got settings and stuff honed down and used full for 3D printed parts. Anyway, here we are with our skeleton face. Yes, the one thing I like about 3D printing robots is, like, this set of teeth, I wouldn't ever do this if I wasn't 3D printing stuff. And like this scoop being so nice angled and stuff, like that wouldn't happen if I was just gonna hand make all of this stuff. The thing I like about 3D printed robots is being able to put nice curves and weird shapes and all that kind of stuff into it, because all I then need to do is set some settings, push some buttons, and there it comes. It's magically like into the world through 3D printing. Yeah. Okay. So there we go. That is our mask ready to go. What I need to work out now is where this guy goes, my servo. So if we snap the servo into here and kind of center that up a little bit, I think actually what we're going to try and do is center the arm a little bit, because that might work a little bit. You 3D printed a midweight? Oh my gosh, that's a lot of plastic. How hard is it to make a featherweight? Yeah, I mean, it depends on how competitive you want to be in featherweights. Where is it? There, behind me? This guy was my first ever featherweight. It is literally steel tubes welded together with some steel from a hardware store as a wedge, drills for the gearboxes, for the drive, and hardware store wheels for the wheels. Like, everything there is from a hardware store, other than the internals that were like the ESCs and the battery and stuff. Like, all of it was from hardware stores. So that was easy. That was like a weekend, I think, to build a featherweight. And I've spent more money on some of my beetle weights than I spent on that thing. But then again, if you want to build stuff like the things above it, so the video game violence, which is my like spinner, sportsman flail spinner, or very, very obvious, that's where you start to get more money and more time and stuff into it. Like, very, very obvious didn't take too long to build. It, yeah. Very, very obvious took like a weekend to actually put together finally, but it took like a week to design so that I could just have all the parts laser cut. So it was a really quick build process. Yeah. And also, I would also be very, very impressed if somebody 3D printed a heavyweight. That would be insane. I mean, it would die very, very, very quickly, but it would be impressive. Having said that, you can get metal printers now, and printers that are essentially just like a welder, which would make for a very interesting heavyweight, I would assume. All right, what I'm going to do is something that I'm quite curious about, is to move this mask 90 degrees in a rotation to see what it looks like rotating about this point. All right, here we go. What? Oh man, there is so much air gap under here. Oh, this thing is going to be a nightmare. Oh. Oh man, this is going to be crazy. However, the good news is, with this up this far, having a wheelie bar out the back here is going to be useful and easy to do. We can just like mount a little prop bar out the back here, and that'll work totally fine. Yeah, that's going to be cool. Oh, this just. Oh, I'm so glad we've gone this way. This is this week's video, because this is for this week. I'm going to have this full robot done and dusted by next Saturday. This is going to be a fun build. I'm so keen for this. Yeah. Oh. This is going to be insane. I love it. I love it to bits. Yeah, so let's see. I'm just going to catch back up on chat. Yes, Maker's Muse did print carbon fiber gears for a competition. I was at the competition where he debuted and used those, and they worked really well. I've personally printed TPU gears for things and didn't use them as effectively as I wanted them to be used, but there's a promise there to 3D print like flexible gears so that in a big hit, you get gears teeth slipping on each other and you lose the mesh of your gears, but you don't snap gear teeth off, which is what he had with the carbon fiber, because carbon fiber is quite strong, but it's also quite brittle. So once you overcome the sheer force of the material, it just goes. Whereas with a TPU gear, you'll actually get them to demesh and they'll survive, I hope, anyway. You remember me getting giddy from collecting the Hardox parts? Yeah, so do I. I remember opening those parts like it was yesterday. They were so nice, and I love getting Hardox parts. I'm gonna do when we get back to doing featherweights in Australia, I'm gonna be doing another round of Hardox parts. I've got a full featherweight sportsman in my mind. I want to get like all the parts laser cut for. That thing, when I get those parts, it's going to be like a giant, beautiful Hardox jigsaw puzzle, and I'm so keen. I haven't even started designing it yet, but I'm so keen for that thing to happen. Imagine something like Tombstone versus Radioactive. If you have a 3D printed heavyweight. Agreed. Yep, that's what's going to happen. You're just going to be sliced into little pieces. Yes, I should modify this to make it look like the Mandalorian, but it is the CAD representation of this, so it's going to look very different in the real world, unfortunately. As much as I'd like to make a Mandalorian mask, I don't have the skills really to CAD a Mandalorian mask, nor do I have the lawyers to fend off Disney when they inevitably come for me with all of their copyright lawsuits and such and so forth. Yeah, Disney's scary. Don't mess with the mouse. That's my advice to you. What were we doing? We were building the arm for this thing. So actually what I might do is I might split this mask down the middle, just so that I can see inside of it a little bit easier, so that I can CAD the inside of it, because as it currently stands, getting into the middle here is a bit of a pain. And I'll also probably wrap the stream up in about 15 minutes, I reckon. Because it's getting very late here in Australia. And I really probably should be going to bed, considering that I do have work tomorrow morning. So, here we go. That's going to be okay, and we'll hide this, and we'll hide that. Oh, and our servo is through the floor. Beautiful. That's not going to help us. So the mask is actually going to go even higher than what I just showed by about 3 mil, which is going to be kind of terrifying. All right, let's just move that further up and just get a measurement from there to there. Okay. Cool. Come on, give me things. There we go. Bam, bam, bam. Nope. Where's my button? There's my button. There we go. Okay, so that's where our servo is going to have to sit inside here. So I'm going to have to do some kind of like a wraparound mount up here to get that to work. I should make a flipper. Yeah, I haven't made too many flippers actually. I really should. I should sit down and make a flipper at some point. Yeah. And yes, it is. Yeah, time zones are annoying, especially for me in Australia because we're so far out from everything else. We're like, where I am, it's like GMT plus 10.5 at the moment, which is crazy. So we are going to build a bent arm. That's going to be the next trick here. I could almost just grab one of these, maybe. What do we think of that? What does that look like? What do you reckon? Do we do a geometric or do we do a curve? I don't know. I'm thinking maybe the geometric because we've got the geometric here. So I'm just going to grab a tooth actually. No, we're going to copy a tooth. There we go. Doesn't really matter because I'm about to literally just, so what's our radii on here? That's 2 mil and you guys are 2 mil. All right, so we actually need to make this thing out to be 4 mil. I'll do proper mountings and stuff on all this later. But we're also going to snip the end off of here because we don't need a sharp pointy tooth, we actually need a flat tooth for what I'm about to do. Bam, come on, get rid of those and those. Cool. So now we're going to snap this onto there. Right. Drat. That's kind of annoying. Oh, but good, because actually we want this piece. That's what we want. We want that on there instead. Have I got... Yeah, I can just... not easily, actually. Come on. Do the thing I want you to do. Thank you. The gap between the mask and the teeth, am I going to fill it? That is a good point. That could be an issue. It does. There is a bit of a gap there. I could actually move the whole mask back a little bit, or I could buff the teeth out. I might try buffing the teeth out, just like slicing them across and pushing the teeth all the way out, just so we've got a bit of teeth jutting out under the mask. I think that might be the way to go. Do I think there should be an official BattleBots Hexbug League? I'd like to see an official BattleBots like kids ant weight league, or like a kids beetle weight league or something. Whether or not they do that like as a TV show or as like filler for the TV show or something, like I would love to see them doing something to like bring in the next generation essentially, because you know, it would be, yeah, it would just be good. It would be good to see them do something that's like heavily kids focused. Like, you know how there's like MasterChef Junior, that type of thing, but for BattleBots. So yeah, doing it as like a US ant weight or an Australian ant weight, just to lower the barrier for entry. I mean, obviously you probably need to go more participant heavy than robot heavy, because like you amp up the kids side of thing to make it a TV show that works. But it would be cool to see. I mean, the big problem, of course, is getting any studio to sign off on that. Like that's the big problem with all of these type of things when you're talking about TV shows and whatever, is getting a studio exec to sit down in a room with you and sign off on that. So even if we pushed really hard for it and the producers of BattleBots wanted to do it, would like even if all of that stuff worked out, still getting an executive into a room and getting them to say yes to that idea could be a very challenging proposition. Okay, so we're almost here with the arm. Let's see if we kind of want to buff this out to there. Is that touching? No, we're just going to push it a little bit more. Okay. All right, so that's our arm. Now I need to make sure that by putting that arm in, that we can still actually do the things we want to do. So how am I going to do that? I'm going to do this for the moment. I know that's sitting inside the servo, but I'll fix that in a minute. Yeah, I agree that the insect weight classes deserve more TV coverage. And look, I think BuggleBots was a great example, or is a great example, of what you can do with the beta weight class. So something like that, like their production quality is insane at the moment, and they're running on no budget at all. Like, imagine if BuggleBots was picked up by a TV station. Oh, the things that they could do with that are amazing. Not that they're not already amazing, but with more budget behind them, they could do some crazy, crazy things. And I would love to see that happen. I'd love those guys to get that level of funding and to, you know, have that level of success. That would be insane. I'd love to see that. And yeah, I mean, like I would love to see more kids participate at a level like that, where there's some, you know, big stakes, big reward, like a purely kid-focused thing, though. I mean, I think the other thing that I'd love to see with that is like modular beta weights, if that makes sense. Like, the kids don't have to do design from square one. There'd be like a chassis chunk, and then motor chunks that they could bolt on, and then a weapon chunk that they could bolt on, and then they could cover it in armor and paint it and all that kind of stuff. That would be really cool. The problem, I guess, is things get a little bit generic-y, maybe, to be on TV. I don't know. I'm just kind of spitballing a little bit here. Yeah, so the mask will have a frame inside of it. I'll glue a frame. Like, I'll have a frame in here that kind of sits across there and then goes up the ridge and then kind of sits across here. And all of that will be glued onto this arm. Speaking of this arm, I need to actually have a look and see how this arm works. So what we're going to do is we're going to do the smart rotate thing again. I'm going to grab this point. I'm going to grab this. I'm going to throw that to 90 degrees. Does that interfere with anything? No. Okay, but we need to be really, really careful of all of our electronics that sit in here, because they are going to be in the danger zone. But if we then also smart rotate, let's just double check to make sure that I had this in the right place before. Grab and go to 270. There it is. Yep, so we're still in the right place. That's still all good. Cool. And yeah, so see, this is the the thing about why I'm going to probably extend the teeth out rather than the mask in, because if I pull the mask in, it's going to connect with the wheels here. I mean, the mask is kind of wide at the top, so it might not. But yeah, we don't want the wheels touching the mask, so I can't drop this mask down any further. I'm going to have to extend these teeth out somehow. Let's see what you guys are saying. It could be, it could be a fun school project. Make generic robots and give options for weapon and armor. Yeah, that's true. I mean, the thing about trying to do TV is it's the inspiration thing, right? Like the point of MasterChef Junior is not necessarily to make those kids famous. The point of that is to like get kids amped up about cooking and doing their own cooking and all of that kind of stuff. So the point of having a TV show would be to have more kids see, oh, this is a thing that I can do with my parents or caregiver or whoever, and I can get involved in this, and then you kind of foster that spirit in them, and you get somebody who grows up and becomes the next Will Bales and spends all of their money and all their friends' money and all their parents' money on building heavyweights and building phenomenal things that, take on Tombstone if Tombstone is still around by the time they get into the sport at that level. Like that's where I want to go. So. Oh, cool. So yeah, I used to teach robotics in high school, actually. High school and university. I did volunteering and teaching robotics with Lego Mindstorms. And then I've started working for an educational robotics company since leaving university. So teaching robotics is a big part of my life. I'm very, very much for more people getting involved in robotics and STEM and all of that kind of stuff. It's good stuff. So... Oh wow, somebody's been up all night. Definitely go to sleep. That's a good idea. I'm also about to go to sleep because it's almost midnight here in Australia, and once it hits midnight, I think we will stop stream and I will go and get some much needed sleep for work tomorrow. But yeah, so there we go. That is the arm. The arm is a little bit suspect at the moment. That's I think that's going to be a little bit interesting in terms of getting that to work, and that seems like it's a little bit off there, but that should be okay. So I'll build this frame up in a second. Actually, we might do the frame now. Just going to fill the last couple of minutes here and build out a little frame. So what I want to do is we're going to take these, and just like everything else in this design, we're going to move stuff around, merge these guys back together, and I'm going to move this over here. You can also see that my CAD design skills, when I CAD design something, this always happens. I always end up with just like this giant pad of parts sitting around and doing all sorts of stuff. I once cut off the top of an RC car and zipped out a pumpkin to the top. My principal was like, that's a cool robot. Yeah, fair enough. I mean, realistically, we all fight robots, but they're just glorified RC cars, so, a RC car with a pumpkin strap to the top, that's gonna be a robot if you want it to be a robot. Sure. I do like that story though. That is quite funny. It's quite an interesting way to get into teaching robotics too. I do like that. All right, so making a 2mm thin strip here. I'm going to copy this 2mm thin strip, and we're going to jump that all the way up to about there. Now, how wide is this? It is a weird width. So we're just going to do 6 mil. 6 mil is a nice number. So what do I need to go down to now? By 7. And we're going to go split. There. Oh, have I missed? No, I haven't missed. Cool. And split. Already split. Splitting entity. This guy. Bam, bam, bam. Okay. So, things are getting a bit interesting around here. But that, and that. These are the pieces we actually want out of this mask. 120. Bam. Although I don't think I need all of this top piece. Oh, but I did say I was going to create a runner. Oh man, this thing's going to be such a weird piece to print. There's all of this kind of flexible, curvy nonsense going on around the front here. That's interesting. Interesting to say the least. Yeah, I don't know how I'm going to print this. It might have to be a multi-part print, or maybe lie it down that way and then print. So this is the back. That might work. But I wondered if I go push pull on here and go out. Yeah, that's not what we want. We want it to go straight out. 0. No, thank you. Go to 0. There we go. Okay. So the idea, I guess, then is to go like this and go like that and go like that. And then raise all that stuff up. Oh. Arm is still in the way. Really should create another point that I can do this off of. 15. Let's take a look. Mullet robot, I like that. Okay. Where was I? We were rotating this gargantuan shape like this. Go to 90, there we go. Okay, so now we can work out how far off the ground this is. So it is 69 millimeters. Okay, well, what can you do, eh? We are going to extrude that distance. Actually, the wheelie bar isn't going to go all that way down. It is going to go 67 millimeters. So that's our wheelie bar. There we go. We're not going to wheelie more than like a little kick back. And yeah, I could 3D print it in separate pieces. I could, if I did it in ABS, then I could acetone weld it all together, which would make it even stronger. Yeah, because I could do these in hoops, basically. Like I could have this side here on the ground. Oh, and I could put notches in it where it needs to have the other hoops. That's the way to do that. It's going to be printed in 3 parts. Yeah. And yeah, it would be good. Be good to see you back over here, Razor. Yeah, I mean, I have no idea when the WA border is going to open back up again. You guys seem to have the hardest border out of everybody, but I mean, that's seems to be what you want over there. So, you know, each their own, I guess. I'm going to rotate this back and we can have a look at how weird this thing looks now. Oh man, this hoop is big. It's a big hoop. Oh, I'm so keen to get this on the printer and get this printing. This is going to be insane. Oh, I really like this. Okay, this design is almost done. We've done the majority of, we've done all the big parts. Basically, all I need to do now is I need to center this up and create the mounting point for this. I need to mount up, or just do the fiddly bits to mount these parts together after they're printed. And then I need to do the mount for the servo and get everything printed. It should be good to go from there. So I think this is probably going to be where I stop this stream. I think we've done a decent amount of work for this evening. Getting this design to go through, and I will extend these teeth so that there's not this gigantic gap between the front of the mask and the teeth. Yeah, although considering that this is going to be a bolt-on addition, I might do 2 different versions and see how I like them in the real world once they've actually been printed. Let me just see where you guys are at the moment. Yeah, use an ABS slurry, use blades for the wheels. No, some people did miss. I am going to be using monster wheels. These things here. For comparison, hang on, I'm going to do this on the actual camera that I have set up. Why am I trying to hold things up? That doesn't make any sense. It has freaked out on me. Don't do the freaking out on me thing. Let's see if I can... see if I can get it to come back again. Nope, come on. Come back. No, my camera's gone down. Okay, that's fun. Anyway. Yes, so we have big wheels rather than small wheels. Yeah, if this camera decided it didn't like me, let's just do this instead. So 1 big wheel, 1 small wheel. These are my normal size wheels. These are the wheels that are going on this absolute monstrosity. To the person who has just joined, I'm literally about to finish streaming, but what you've come in on is we're making a mask that looks like this into a combat robot, and we're using just ridiculous wheels to do that job. Yeah, so that's a thing. Anyway, I think with the camera going down, that is going to be it for me for today. Thank you guys for coming along and joining in with the stream. This has been a lot of fun, and we've ended up with something way weirder than I would have come up with on my own. So thank you guys for that. This one is on you. I'm gonna give you at least 50% of the blame here, or the glory, I guess. We'll see. We'll see how this goes once I actually get it together as an actual combat robot. Anyway, we'll see you in the next one.